You know that raw power you see in a volcano? What if I told you that same energy could be used for something, well, a lot more every day, like heating your house, growing your food, or even, get this, cooling an ice museum? Yeah, when most of us think geothermal energy, this is probably what comes to mind, right? Something dramatic, powerful, almost mythical. These incredible places where the Earth's raw heat just bursts right out to the surface. But here's the thing, that spectacular show, that's just a tiny piece of the whole puzzle. Today, we're going to look past the big power plants and dive into something called direct use geothermal. It's this incredibly versatile tech that's, well, quietly changing everything. How we heat our homes, grow food, you name it. All by using heat literally straight from the ground. All right, so here's our game plan. First, we're going beyond volcanoes to figure out what this direct use thing is all about. Then, we'll crack the temperature code. That's the key to its potential. After that, a tour of the unexpected to see it in action. We'll size up this quiet revolution. And finally, we'll talk about why this hidden power source really, really matters. Okay, let's get into it. First up, what exactly is direct use? I mean, like I said, most of us hear geothermal and immediately think of those giant power plants making electricity. But that is really only half the story. So direct use is, well, it's pretty much exactly what it sounds like. Instead of all the complicated steps to turn heat into electricity, we're just using the heat directly. We're piping that naturally hot water or steam straight to where we need it. It's all about tapping into this super consistent, super reliable source of heat for all kinds of things we do every day. And the secret to unlocking all this potential? It really comes down to one simple thing: temperature. See, not all the hot water under the ground is boiling hot, not hot enough for a massive power plant. But, and this is the key part, that doesn't make it any less valuable. Okay, check this out. This chart is called a Lindell diagram. And honestly, it's the key to everything. See, way up at the top, you need super hot temperatures, like 300 degrees Celsius, for power generation. But look what happens as you go down the scale. Even kind of lukewarm water, maybe 30 or 40 degrees, is still perfect for things like heating a swimming pool or totally changing the game for fish farming. The big takeaway here? Every temperature has a job it can do. And this idea leads to some incredible efficiency. They call it cascade uses. So just imagine this. You use some really hot water for a big industrial process. But then, instead of just dumping that water, which is still pretty warm, you pipe it over to a nearby neighborhood to heat their homes. It's brilliant, right? You're basically squeezing every last bit of useful energy out of that water before it cycles back into the ground. Okay, so that's the theory, but what does this stuff actually look like out in the real world? Let's take a little tour of some pretty amazing examples where this all comes to life. One of the biggest and most powerful ways to use this is something called district heating. So you can see in the diagram here, you pump hot water from way underground, it goes through a heat exchanger, which warms up a totally separate loop of clean water. And that water gets piped all over a city to heat everything: houses, big apartment buildings, you name it. The picture on the right, that's Reykjavik, Iceland, a city that basically runs on this. And the scale here, it's just staggering. We're talking over 90%, 90 of all the homes in Iceland are heated this way. Just let that sink in for a second. An entire country has pretty much kicked fossil fuels to the curb for heating, all by using the clean energy that's literally right under their feet. But it's not just about heating cities. The list of uses is just wild. That steady, reliable heat is perfect for fish farming. It can boost growth rates like you wouldn't believe. You can run greenhouses year-round, growing tomatoes in the dead of winter. It's used for drying food, like cod heads that get exported. And here's the real mind bender. You can even use this heat to create cold. Yeah, through a process called absorption chilling, that heat can power a cooling system. There's an ice museum in Alaska that's cooled this way. How cool is that? So we've seen some of the amazing things it can do. But just how big is this quiet energy revolution, really? Let's zoom out and look at the global picture. Now, the number one use here, it might actually surprise you. It's not those huge citywide heating systems or big factories. It's geothermal heat pumps for individual homes and buildings. They make up more than half of all direct use. And the reason is you can put them almost anywhere on Earth because they just tap into the stable, milder temperatures just a little ways underground. And this is not just an Iceland thing, not by a long shot. You've got global players like China, the US, and Sweden who are all in on this, deploying this tech on a massive scale. We're talking everything from those huge city heating systems to millions and millions of individual heat pumps. And the trend line? It's undeniable. Ever since the 90s, the use of direct geothermal has just been shooting upwards. This isn't some niche experimental tech anymore. It is a rapidly expanding global energy solution, and more countries are investing in this incredibly reliable, homegrown power source. Okay, so this brings us to the most crucial point, understanding the real-world impact of all this. Why does this hidden power source matter so much? It's not just about the cool, clever uses. It's about some really significant benefits for the planet and our economies. So, let's talk about why this matters. The impact on the climate is just enormous. Take a look at this table. It shows the CO2 savings every year just by replacing fuel oil. If you look at the total, we're talking about preventing over 148 million tons of CO2 from hitting the atmosphere every single year. To put that into perspective for you, that's like taking more than 32 million cars off the road. For good. And yet, despite all of this, the flexibility, the reliability, the huge carbon savings, the source material we looked at ends with this really powerful thought. For all of its success, for all it can do, geothermal energy is still largely invisible to most people. I mean, the tech is proven, the potential is absolutely vast, and the benefits couldn't be clearer. So that leaves us with one big question, right? With all this clean, reliable energy just waiting right there beneath our feet, what's it going to take to finally bring this hidden power source into the light?